Hello everyone, in this video I will explain chapter 13 Antiderivatives for second humanity class. Objectives are 1. Define the antiderivative. 2. Set up a list of antiderivatives. 3. Prove the linear properties to find the antiderivatives of functions. Now before I begin, I wish from you to make a revision of all properties of derivatives because they form a base of this chapter. Paragraph number 1. Derivative of a power. Main property ax power n f prime a n x n minus 1. Multiply n by a, subtract 1 to get a new power n minus 1. Example number 1. f of x 3x power 5. Multiply 5 by 3 to get a new power 4. 5 minus 1, as you see, 15x power 4. Now example number 2. f of x 1 over 6x power 5, a 1 over 6, and equal 5. Now multiply 6 by 1 over 6 and subtract 1 from the power to get 1 over 6 times 6. Now 6 and 6 carry out. It is easy to write it's 6 over 6. Now carry out to get the final answer x power 5. Example number 3. How do you find the derivative of f of x? f of x has 3 terms. Derive each term alone. f of x equal, as you see it, then f prime. 3 multiplied by 3, 1. Subtract 1, a new power is 2. Derive x squared minus 2x. Derive of 5, 0. Now, paragraph number 2. Let f be a continuous function. The differentiable function capital F is called antiderivative or primitive of small f if and only if derivative of capital F equals small f. I repeat, if derivative of capital F equals small f, then this capital F is called antiderivative of f. Example. Direct examples. Example number 1. Given f of x and capital F of x. Aim is to show that capital F of x is the antiderivative. Simply make a derivative of capital. Now, derive capital X, capital F of x, 4x minus 2 equals small f of x. Conclusion, capital F is called antiderivative of small. Example number 2. Given f and capital F, derive capital F, 3 carry out, subtract 1. 3 multiplied by 2, 6 by 2, 2. Subtract 1 from 2 to get power 1. Now carry out, equal x squared minus 3x, which is f of x. Simply we prove derivation of capital equals small, then capital F is called antiderivative of small f. Paragraph number 3. Definition and notation. Let capital F be the antiderivative of small f. Then the set of all antiderivatives is denoted by integral f of x dx equal capital F of x plus c. Now, c is called a real constant. The symbol is called integral. This symbol is called integral. Notation, integral f of x dx is read integral of the function f of x. Now, terminology. Integral f of x dx equal capital F of x plus c. When we write integral f of x dx equal capital F of x plus c, there is a condition. Derivation of capital F of x should be small f of x. فإذا هيدا مصطلح عم نتعرف على هاي السيمبل اسمه integral. هاي كلها بنقراها integral f of x dx. dx is called increment of x. Keep this definition in your mind. I repeat, integral f of x dx equal capital F of x if and only if derivative of capital equal small. Derivative of capital, as you see, equal small. Now, example, integral to x dx equal, you may say x squared plus 0. Why? Simply derive x squared plus 0 to x. You may say x squared plus 1. Derive it to get to x. You may say x squared plus 2, and so on. You may say x squared plus c. Derive to get to x. Derivative of c, whatever c is a constant, equal to 0. Then integral to x dx, all these answers are true. Now, complete the following. Integral 1 dx equal integral dx. Do you expect the answer? I wait. You, the student, says the answer should be x plus c, simply because derivative of x plus c equal to 1. And when we write 1 dx equal integral dx. I repeat, since derivative of x plus c equal to 1, then integral of dx equal x plus c. Notation, remember it. Integral f of x equal capital if and only if derivative of capital equal small. Now integral to x dx. Can you suggest the answer? The answer should be x squared plus c, simply because derivative of x squared equal to x. Now, 3, x power 5 dx. Do you expect the answer? The answer should be x power 6 over 6, simply because derivative x power 6 over 6 equal x power 5. Derivative of x power 6 over 6 equal x power 5, then integral x power 5 equal to x power 6 over 6. Now, 4. More general, integral xn dx should be xn plus 1 over n plus 1. But then as you see, 5 add 1, the power becomes 6, and add 1, the power becomes 1, and divide by a new power. In this case, a new power 6, we divide by it. In this case, a new power n plus 1, we divide by it. Why? Since the derivation of this equal n plus 1 multiplied by n plus 1 and subtract 1 from the power. Now carry out x power n. It is the basic property of my chapter. Now, how to transform from radicals into rational exponents and vice versa. This property was studied in the first secondary class. Radical nth root of x power m equal xm over n. Index refers to the denominator and the powers refers to numerator. Keep it on your mind. Index is written in denominator. Examples, write the answers in the form x power q. X radical x, radical x, x power 1, radical x, x power half, index 2, power 1. When we write radical x, it means that the index is 2. Now, same base, we add the powers, 1 plus 1 over 2, 3 over 2. And the answer is of the form x power q. Now, radical x over cubic root x squared. Radical x, x power half, cubic root x squared, x2 divided by 3. Index refers to denominator. Now, same base. In the case of quotient, we subtract the powers to get x power minus 1 over 6. And 1 over x power minus 2, x power minus 2 is written in numerator in the form of positive exponent. Examples: transforms from power into radicals. X3 over 2. 2 is the denominator, refers to the index. 3 power and so on. X squared times x cubed can be viewed as x squared times x. Now x squared carry out x radical x. Similarly for final case. Now, paragraph number 4, properties of integration. Integral dx. Can you suggest the answer? Yes, the answer should be x plus c, simply because derivative of x plus c equal 1. 2. Integral x and dx. The answer should be xn plus 1 over n plus 1. Add 1 to get a new power and divide by it. 3. Integral dx over x squared minus 1 over x plus c. I prove it. 4. Integral of x dx. Definition, I remember you by definition. 5. Integral dx over radical x to radical x, and later I prove it. 5. Integral sum or difference of two functions equal their sum. We split the integral. Now each function is integrated alone. Now radical x dx 2 over 3x radical x plus c. Integral kf of x dx constant is written alone, then integrate f of x. All these properties should be memorized. They form the effective tools of my chapter. I prove some of them. Now, proof of 3. Integral dx over x squared equal minus 1 over x. To prove it, we should write it in which form? In the form of x and dx. Now 1 over x squared in a numerator, x power minus 2. Now it is of the form x and dx, n equal minus 2. We add 1 to the power and divide by a new power. To solve the integral, listen to me. To solve this integral, we add 1 to the power and divide by it. Now x minus 1 over minus 1 plus c. c is kept alone. c is written alone in all cases. X minus 1 in a numerator. X, we have minus. Now minus 1 over x plus c, which is the property. Now proof of 7. Integral radical x dx 2 over 3 x radical x plus c. Integral radical x dx. To prove this property, radical x dx should be written in the form x power n dx. Radical x equal x power half dx. Now this form and this form are identical in a way that n equal half. Now add 1 to the power, as you see, divide by a new power. Add 1 to a power and divide by a new power, x3 over 2 over 3 over 2. Now x3 over 2 over 1, extreme by extreme or mean by mean to get 2 over 3. Listen to me, over 3 over 2 equal 2 over 3 is converted to 2 over 3x3 over 2. Now the final answer should be expressed in the form of radical 2 denominator refers to the index, and 3 numerator refers to the power. X cube, x radical x. And integral radical x dx now equals to 2 over 3 x radical x plus c. Important property should be memorized. Now, example, solve the integral. Integral x to the power 5 dx, it is a direct application of the main property. N equal 5, now add 1, new power 6 divided by 6 plus c. c is written alone. 2. Integral difference of these two functions, split the integral over the first and over the second. Now 3 is written alone outside the integral. Also 5 is written alone inside the integral. Now integral x squared dx, it is of the form x and dx. Add 1 to the power, new power 3. Now divide by it. X dx, also it is of the form x and dx, where n equal to 1. When we write x, it means x power 1. Now add 1, 1 plus 1, 2, divided by 2 plus c, equal x cubed minus 5x squared over 2 plus c. c is written alone. Keep in your mind that c should be written alone. Now, integral dx over x cubed. To solve this integral or to facilitate the solution of this integral should be expressed of the form of x and dx. Now dx over x cubed means 1 over x cubed dx. Now to the numerator, x power minus 3 dx. It is of the form x and dx, where n equal minus 3. In a similar way, add 1 to the power. It becomes minus 2. Now divide by it. The answer should be expressed in positive exponent. Listen to me. The answer should be expressed in positive exponent. Now x minus 2 in the numerator x squared minus 1 over 2x squared plus c, the final answer. Now, integral x radical x minus x squared over x. Now, split or distribute x over these two expressions, as you see. Equal integral x to x carry out radical x, x squared to x simplify to get x. Now, split the integral or distribute integral over the first and over the second. Equal radical x dx, it is a property. I prove it. 2 over 3x radical x. Now x dx, x squared over 2 plus c. Please pause the video and try to solve them before go into application. Now, application. Let a of x equal b of x equal. Part 1, solve a of x. B, determine a of x, satisfy a of 1 equal to 0. Solution. Integral a of x, x radical x dx. To solve x radical x dx, transform radical x into power. Now x power 1 times x power half. Now they have the same base, which is x. We add the powers 3 over 2. Now it is of the form of x power and the x, the basic property of my chapter. Add 1 to get a new power and divide by it. 3 over 2 plus 1, 5 over 2, divided by 5 over 2. The answer 2 over 5. Focus with me. The answer 2 over 5. X power 5 over 2. As usual ways, the powers should be transformed into radical. Now, write it 2 radical x power 5. Now x power 5 can be viewed as x squared x. x squared is repeated 2 times in case of multiplication under the radical is written outside radical as 2 over 5 x power squared radical x plus c. Now, a of x equal 2 over 5 x squared radical x plus c. Now determine a of x so that a of 1 equal to 0. This condition is called the initial condition. It means that for x equal to 1, a of x equal to 0. That is, substitute x by 1 to get your answer 0. Replace x by 1 as you see, plus c equal to 0. Don't forget a of 1, 0. The answer should be 0. Then c equal minus 2 over 5. Now substitute c by its value to get a of x equal 2 over 5 x squared radical x minus 2 over 5. Part B. Integral x power 5 minus 2 over x squared. Now split x squared over both terms. As you see, x cubed over x squared, x cubed, 2 over x squared dx. Now, x cubed dx, distribute the integral, minus 2 constant outside integral alone, integral dx over x squared, complete. X cubed dx minus 2 dx over x power 2. X cubed, add 1, 4, divide by a new power. Now, integral dx over x squared, it is a property, I prove it, equal minus 1 over x plus c alone. Now, multiply minus minus plus c, part B, b of x equal initial condition, b of 2 equal minus 1. In all cases, we use initial condition to determine a value of c. Replace x by 2 2 power 5 over 4 plus 2 over 2 plus c equal minus 1. Don't forget a of 2 equal minus 1. The answer should be minus 1. Now calculate c to get c equal minus 6. Then b of x equal x power 4 over 4 plus 2 over x minus 6. I substitute c by its value. Thanks for your listening. ويعطيكم ألف عافية.